Gomer here with my introductory video on gitsync. What I intend to explain is what it is, what do you need to run it, what's it good for, how do you install the two scripts, and how do you set up the nodes. And there are three types of nodes. There's a peerless node for non-network functionality, pull peers and push peers, which I'll explain in a minute. Okay, what it is a system to record changes automatically to a directory and its subdirectory. Because it uses Git, you get versioning. If you use pull peers and push peers, you can synchronize files over a network with eventual consistency that's secure because we use SSH. I already mentioned some types for the peering. A pull peer is where you pull your changes from a remote host. A push peer is where you push your changes to a remote host. And we use push peers because if you can't get through a firewall, that's what a push peer is good for. Pull peers are much more efficient. To run gitsync, you need SSH only if you're going to run it in a networked system. If you're using it peerless, you don't need SSH. You'll need rsync, iNotify tools, Git, and bash. If you have daemon tools from Dr. Bernstein, you can set up multi-log and get much better logging, but you need to set that up yourself. What gitsync is suitable for is source code, other text files, or configuration files. Application files is not as suitable for because Git doesn't know how to version them unless you tell Git how to version the application files. It's not suitable for media files because they're large and versioning them doesn't do you much good. Here's the usage for the install script, and we'll get into more of this later, but basically if you're going to use it networked, you supply the user, the host, and the directory, and whether you're going to push or you're going to pull. This WO is write only and RO is read only, and there's also a mode for read write, which we'll talk about in a minute. Right now. Okay, modes of operation. If you set up a read only node, you're setting up a reference copy for changes made remotely. It's going to ignore all local changes, which means if you make changes to the directory, they will be overwritten and they won't be recorded anyway. That's what a read only node is for. It's a reference copy for a database that's remote. If you have a write-only node, the exact opposite. It's going to track your changes locally. It's going to ignore any remote changes. Anybody who pushes changes to you, if you set up your node write-only, it's going to ignore those changes. And the read-write is tracking changes on your local machine and on peers that push to you or that you pull from. Here's a network diagram showing where pull peers would be very useful. A, B, and C are on the same LAN segment. They can SSH to each other. Therefore, you can set these up as pull peers of each other, and very efficiently, you'll be able to track changes on all three machines, depending on how you set up the nodes. If you set them all up read-write, then all nodes will reflect all changes on any of the three nodes. Here's a diagram where you have a router in the way, so without any holes in the firewall. So A cannot see B. B can pull from A, but not the reverse. So you set up on B that A is a push peer, and then B would push its changes to A. That's where a push peer would be useful. In this case, you have a firewall restriction. Here's an example of a config file, which is just environment variables that have been exported. This config file is sourced on every invocation through cron, which we'll get into later. So changes you make to the configuration file are in effect within a minute or two. Okay, when you set up gitsync, you'll need a cron entry, which I mentioned just a second ago, and we'll get into more of that later. And the administrator must install the software to some common location, and for Linux it's user local bin. It's a very simple make file. It just copies the scripts into user local bin. Here's an example cron entry where what I haven't read is the directory you want to monitor, and again it's this directory and its subdirectories, excluding this administrative directory. The .gitsync directory is a lot like the .git directory in Git. It's administrative, and everything under that is untracked but is used by gitsync to keep state. These configuration variables are defined in the config file. So here you see the cron entry where you source the config file and execute the script, writing the output to the log file. Here again I say changes to the config file take effect within 2 minutes. That's because you're sourcing it every minute. Okay, to install there's only 2 scripts. It's gitsync and gitsync install. Here's the make file. It just copies the 2 scripts into the user local bin and then lists them out so you can verify it. Okay, here's the first node type. It's a peerless node. It's simplest. It just records your changes in the changes you make on your local machine and its subdirectories. And it will also do it for large files too, so that's where it's not so appropriate. But if you have like in a home directory where you have nothing but source code and so forth, you might set up gitsync peerless just so that you don't even have to record you don't even have to make git commits. It will do everything for you. Of course, it's going to do it at a very granular level, but it will record all changes. If you set up a pull peer, you're recording changes made on a remote machine. You must be able to SSH that remote machine, and you would invoke gitsync install, and you do and specify pull and the user host and directory where the existing gitsync node is. You want to invoke this from an empty directory, and that will be the directory that's a clone or a reference copy of the remote repository. Initially, when you do this, the node that you're setting up will be a read-only node, which I already mentioned means that it's going to ignore local changes. You can change that later. If you set up a push peer, again, you must be able to SSH to the remote machine, but this time you're going to record your local changes to the remote machine. You want to invoke this from an existing gitsync node, and the gitsync install syntax just specifies push, and again, what user host and directory you want to push into. This script will create the remote directory and the database and set everything up for you, including your remote links within Git. All right, here's an example, and I'll go through this in a subsequent video where we will actually go through and set up this configuration where Mercury will start out as a peerless, then we'll add Venus, which will pull changes from Mercury, and then we'll add Pluto, where Venus will push to Pluto. And in this setup, Mercury can't see through the router, so it can't pull from Venus or Pluto. Venus has a firewall on it, so Pluto can't SSH into Venus, which is why in this contrived configuration, Venus will be pushing its changes to Pluto. And again, I'll do this in a subsequent video. Thanks for listening, and look out for my subsequent videos.